Testing. Okay. Right. 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 So how about my audio? Is it clear and the video? Let me also check. Right. So how about my audio? Oh, it's fine, right? Right. Right. Give me 2 minutes. I'll share this live to the group and come. One second. Okay. Right. We'll start. Okay. Good afternoon. Good afternoon again. We'll start now. Right. Clear. Okay. Right. Good. Listen. So as planned, we are going to start friction today, right? And you all know that we have to called off the class for the last week. We had to give a holiday in the last week because of the flood disaster condition and the consequences of it in the country, right? So for now also, I mean, until now also, there are some areas where still they don't have electricity, which means power outages are there, water outages are there. Still, the issue is there, but it is getting better day by day. It's true, but it is not fully recovered to the previous state that was before, right? So therefore, still some things are happening around, and for the hill countries like central highlands of the country, now again the monsoon season has started and landslide warnings are issued again, because with the heavy rainfall we had in that week, that storm week, now soil layers are already, they have been unstable. So therefore with the monsoon rain, then that is going to come, and it's already happening, already started for the areas like Kandy, Madulla, those areas. And for some areas, they have already instructed to leave the houses and go to some safe places. So therefore, risk is still there, right? And so in this class also, I know there are some students who got affected due to flood, landslide, maybe storms and everything. And from the ones I can remember, as they are from Kandio, Mathaleo around, I actually asked how their condition is, and some students were asking about my condition as well. And for our area, it was kind of okay, because as a river basin, River Kalu didn't get that much of rainfall this time. The main river basins, it got the rainfall was Kalani and Mahavalinu. So therefore, those river basins were very much affected. Right? I'm from Horana, so it's in Kaludara district. The closest river for us is Kalu, right? But the rainfall for that area was not that high compared to other areas. So therefore, we were actually safe during the period. And yes, you might have seen that I have shared one flyer in that flood week regarding the free classes for the students who got affected, right? So what I need to say you again is, if you know anyone who has got affected from it, right, you can ask them to contact me, because from our side, that is one thing we can do, that allowing them to join the class free until they are sitting for the exam, not just for a month or 2 months of time. It will be until they are sitting for the exam, right? If they are affected, doesn't matter whether they are 26 or 27, until they are sitting for the exam, it will be free, totally free in the sense they are getting all the tudes, everything that you are getting, and the class will be 100% free without any conditions, right? So that's what I can do from my side. That's why I shared that flyer. So if you know anyone who got affected and who need that support, right, you can share it and ask them to join the class, because I don't get any advantage if someone join the class. The only thing is I can support them. Actually, I don't get any advantage, and for me, it's not going to be free, because that's a cost component involved for that particular student. So that's a support I can give, right? So therefore, class will be free. Doesn't matter whether 26 or 27. For 26 students, now they have only 8 months for the exam, and for you, you have around 20 months for the exam, right? So it will be free anyway. That's one thing. And the other thing is, from your side also, try to help each other as much as possible during this period, because still we are in the recovery period, not recovered fully. Still we are in the recovery period of this, right? So therefore, try to help as much as possible. Like if someone has lost their notes, tudes maybe, right? So what you can do is you can provide your notes, right? Don't think twice, just provide your notes without thinking twice. And if they seek something, maybe tudes, right, or something else, right, try to help as much as possible, right? So the last class we had was an online one. I think the date was 31st, right? 31st. No, 28th. The last class we had was the online class, 28th, and the last week, 5th of December, I have to call off because of the consequences of this, right? Because the storm was developed to the cyclone state by Saturday, right? We had the class online on Friday, no? So after Saturday only, it developed to the cyclone state, right? So since there is some physics part also involved behind that, I think some of you might have seen the video. I uploaded a video discussing what is happening with the storm in terms of physics, because those are the lessons that we have in our syllabus. I explained using the lessons we have in our syllabus, especially fluid dynamics, Bernoulli's theorem, and hygrometry in thermal physics, right? So those are the parts involved behind the storm happened, because for anything there is a physics part involved, no? That is what I wanted to explain you. If you didn't see that video, you better go and check it out, because now initially also it was identified as a storm but not a cyclone. It developed by decreasing pressure. So there are a physics part is involved, right? So that's what I wanted to share with you that day, because I also gave holidays for the entire week after your class, your online class. It was the last class I had for that week, and from that Friday to next Monday, actually, for all 9 days, I had to give holidays for all the classes I had, and actually I dedicated my time for the donations and some of those kind of things. If you are in my WhatsApp and other social media, so sometimes you might have seen it, right? So in our area in the sense, actually I went for donations in Avisavale area, that is somewhat close to our area, and by the time we went there also, on that day afternoon only, their flood level has gone down, and when we are going for the donations also, we had to cross the flood by foot in some places, right? We went on 2 trucks, and in some places we had to drive the truck in flood water, and in some places we had to get into the water and go to some houses because they were isolated. We went for an isolated village in a remote village in somewhere around Isavale, right? So that's what basically I did during the period. Now what I need to tell you is, doesn't matter by any means how you are going to do the donations, right? Maybe a very small thing, but it matters. So therefore try to help as much as possible, right? And for the donations I did, your contribution was also there, so therefore you have also contributed, because I donated by my personal money, no? So that means they are coming from class fee and all those things, right? So which means you have already contributed there, right? So I'm just sharing because you can be happy about that, because you have also donated, you have a contribution, you have contributed already, right? මම ගියා කියන්නේ ඉතින් ඕගොල්ලෝ ගියා කියන එක තමයි. Right. Especially the ones who are living in mountainous areas, right? Central Highlands. Stay safe and try to help each other if you are not affected. If you are affected, don't hesitate to ask if there's anything, from me, maybe youth or any other thing. Don't hesitate to ask anything. You can always contact me if there's anything, right? මට මැසේජ් කරපු ස්ටුඩන්ට්ස්ලටත් මම ඒක කිව්වා. මේ මම දැන් ආයි ක්ලාස් එකෙත් කිව්වේ හැමෝටම මේක කියන්න නිසා, right? නැත්නම් සමහර කට්ටිය මේ මට මැසේජ් කරපු අය ඉන්නවා, ටියුට්ස් ටික නැති වුණා කියලා මැසේජ් කරපු ළමයි හිටියා. මේ එහෙම තියෙනවා. ඒක natural disaster එකක්නේ. natural disaster එකක්. Right? That's the thing. But more than 1 week before the disaster, it was very clearly updated in some of the websites. Right? මම මේක ඔයගොල්ලෝ ක්ලාස් එකේ කිව්වද කියලා මට මතක නැහැ. මම ඒ ස්ටෝම් එක ආපු වීක් එකේ මන්ඩේ තිබ්බ පේපර් ක්ලාස් එකේයි ටියුස්ඩේ තිබ්බ ක්ලාස් එකේයි දෙකේම මම ඒක ගැන කිව්වා. දවස් ගානක් කලින් Thursday the storm is going to come කියලා. It was updated. Right? So ඉතින් අපේ meteorological department එකට වඩා පොඩ්ඩක් දෙයක් මොනවා හරි කරන්න තිබ්බා. awareness එකක් එච්චර ලොකුවට හැදුවේ නැහැනේ. ඒක they informed but ඒක මදි. මිනිස්සු අයින් no one left. That's the thing. මදි ඒ severity එක එච්චර මිනිස්සුන්ට තේරෙන්න කිව්වේ නැහැ. They said that a storm is coming. ඒකත් කිව්වේ Wednesday වගේ. Right? Wednesday ඒක අප්ඩේට් ලා තිබ්බේ Wednesday night එනවා කියලා. ඒතර Wednesday තමයි කිව්වේ. Thursday means it is started already. කියන්නේ Wednesday night නේ storm එකේ පළවෙනි pressure depression එක ආවේ. Yeah, heavy උනේ එතන අරක start උනේ Wednesday night. ඒක හරියට අප්ඩේට් ලා තිබ්බා. rainfall එකත් expect කරලා තිබ්බා around 200 something ඔය වගේ තිබ්බා. Because I checked it in the week before, the weekend before that week, because I went on a trip. So මම trip එක යන නිසා මම usually බලන websites එකක් තියෙනවා. මම ඒ දෙක බැලුවා. ඒ දෙකේම ඔක update වෙලා තිබ්බා. Okay, anyways, මම දැන් මේ websites mention කරන්න නැතුව ඉන්නම්. In that video I have mentioned the websites. ඒ websites වලින් ඉතින් බලන්නත් පුළුවන්, because until waiting you are hearing it from news, right? Because in media sometimes the reality is not revealed by the media. සමහරවිට severity එක reveal කරන්නෙත් නැහැ. Number of death count, that is also now it's varying around 650 700 or something like that. ඒකට වඩා ගොඩක් වැඩි. සමහර ඒවා ඇත්තටම හොයාගන්න බෑ. සමහර ඒවා reveal කරන්නෙත් නැහැ. because the misplaced count is also already dead now. Then more than 1 week ඒගොල්ලෝ misplaced නේ. They are dead. So ඒ count එකත් අතන add කරාම ලොකු count එකක් දැන් ඇත්තටම dead. And there are some people who are not in those records. Right? Records වල නැති අය ඉන්නවා. ඒතර දන්නේවත් නැහැ මොනවද කියලා. Right? So I think around 1,300 400 people should be dead if the official count for now is 700. Around 700 දැන් තියෙනවා 650 700 වගේ නේ යන්නේ. ඔතන දැන් misplaced list එකත් 400 500 වගේ ඉන්නවා. ඒතර එතන ලොකු ගාණක්. Right. ඒතර the disaster this time is severe than we think. Right? It's severe. Right. So be safe. Right? Okay. As students who are learning physics, you better know these things. That's why I upload the video. Video එකත් නිකන් ඉන්න වෙලාවක බලන්න. It is in the channel. නිකන් බලන්නේ video එකේ මොකක්ද තියෙන්නේ කියලා. මේ 26 ආරේ එක ටිකක් තේරෙනවා. ඔයගොල්ලන්ට තාම මේ lessons දෙකම තිබ්බේ නැති නිසා ලොකු idea එකක් නැති. But still you can watch it. තව එකක් ආවොත් එතකොට දන්නවනේ කොහොමද මේ storm එක එන්නේ කියලා. Right? This is not the last storm that came, no. Right? There can be more disasters in the future. That's how it is. Right? With the human activities, right, and everything, maybe improper constructions, infrastructure development, right, by everything, if the nature is got affected, right, what nature does is it takes what we call revenge, right, because anyone can't go beyond that thing. We are just a part of nature. But nature එක පහු කරලා යන්න බෑනේ. We are just a part of nature. We are not the owners of nature. අර දැන් අපේ කට්ටිය ඉඳන්නේ අපි නිකන් owners ලා වගේ. එහෙම වෙන්නේ නැහැ. අපිට මේ battle එක win කරන්නත් බෑ. Because we are just a small part, a micro part in nature. Right? Human beings can put micro part යන්නේ. ඊට වඩා කොච්චර දේවල් තියෙනවද nature එකේ. Right? So therefore if you do something, definitely it will take the revenge. එහෙම වෙනවා. Right? So for most of the landslides and maybe floods, the ultimate, if we just dig down and see it, right, the ultimate root cause is some human involvement somewhere. Maybe some improper infrastructure development. කොහේද දැන් කන්දක් උඩ හොටෙල් එකක් ගහනවා. ගහපුවාම අර ground water flow එක block වෙනවා. block වුණාම ඉතින් ඒක හෙට landslide එක වෙන්න it may take like 6 years 10 years 12 years, but one day it will be sliding. The land will be sliding. එහෙම වෙනවා. Natural water flow එක පුළුවන් තරම් අපි protect කරන්න ඕනේ. නැත්නම් ඒක වෙනවා. Right? Business mindset එකෙන් කරන වැඩත් එක්ක තමයි ඔය ගොඩක් වෙන්නේ. ඊට පස්සේ flood වලටත් එහෙම තමයි. When lowland areas are maybe filled and constructions are done, infrastructure developments are done, right? එහෙම වෙනවා. Right? So therefore what we need to take as a learning from this is any human being can't go beyond the nature's science. That's a different thing. අපි මොන impact එකක් කරත් it has its own way of recovering. ඔය recovery එකක් වෙන්නේ. ඔය අත්‍තරම recovery එකක් වෙන්නේ. ඔය landslide එකෙන් ගැලවිලා ගියේ එතන තියෙන්න ඕනේ නැති දේවල්. ඇත්තටම. ඒ කියන්නේ ඒකට harm වෙච්ච දෙයක්. ඊට පස්සේ දැන් it takes like 10-15 years to recover. දැන් කන්දක් landslide වුණා කියනවා. වුණා නම් එයා එතන recover වෙලා ඊට පස්සේ ඊට වඩා හොඳට හැදෙනවා. naturally එහෙම cycle එකක් තියෙනවා. That's a cycle. So yeah, it does its own recovery. දැන් ඔය recovering period එකක ඉන්නේ. එහෙම තමයි. All right. And the videos, yeah, on the channel. And one more announcement. Listen, one more announcement about the paper class. Right? I got few inquiries after the flyer as well. Now I have planned to start your paper class next Wednesday. What's the date? 19th, right? 17th. Next Wednesday. 17th. I have already shared these flyers and I'll remind you again in the channels and the group. We are planning to start on 17th, right? 17th Wednesday, and the planned time is 6:30. 6:30 means it will go up until like 9:30. It will go up until 9:30. Okay. Something like this. 6:30 to 9:30. Right. So basically, what we are doing here is, right, I'm saying this because I didn't meet you last week, so therefore I didn't get a chance to say anything about the paper class, and since it was planned, actually it was planned for this week, right? It has been planned for this week, and since I had to give holidays for all the classes for a week, all the scheduled classes were shifted by a week, shifted forward by a week. So that's how it went up to 17th. Otherwise, it was planned for 12th, right? Okay, and here what we are going to do is something like this. What we are going to do is something like this. Now today I have changed the tips. That's why it is still sharp. Right. And this will go like this. So mainly we'll be writing and discussing exam standard target papers, right, from the first day onwards, right? And for the first 2 to 3 months of first period, I mean, what I need to do is, and what I want to do is, I need to discuss more types of questions with you to make you aware about the question types that it's coming from these parts, right? And I'm not going to care any mark that you are going to get for the papers, right? Not the mark for the first 3 weeks. That is all about the question types to broaden up your knowledge in first weeks. Now, as an example, let's say now we have finished, say, Newton's laws. Now, from Newton's laws, what are the question types that you are going to get in an exam? Something like that. From center of gravity, what are the question types you are going to get at the exam, right? So something like that. So therefore, in first like 2 to 3 months, we'll be writing different types of questions, and I'll be discussing them all with you in the class to broaden your knowledge, because now still you can write questions up until center of gravity only. Now today we are starting friction, so after friction is done, I'll be adding friction questions as well. So likewise, you will be getting questions up until the point that you have covered in the theory class, right? Something like that. And after 3 months of time, we'll be focusing on the accuracy of the answers and correct approaches, timings. There are a few more things to be developed now. First thing is getting the experience of the question types we have, and then only you can do it by your own, and then only you can improve your timings, right? The mulimma timing hadanna bane. First thing is accuracy. If the accuracy is there, timing can be attainable very easily if the accuracy is there. Accuracy එක නැත්තම් timing හදුවා කියලා වැඩකුත් නැහැ, right? So that is how it is going to go. And then finally you are going to write the paper on a separate day, and we are going to get a separate day in the sense this day only for the discussion purpose, right? So that is how 26 paper class is going now. So for you also it will be same by the time you are reaching there, right? Then you can write the paper on a separate day, physically or online, whatever it is, and come to the discussion at this time, right? And about the past papers, since some students asked, for past papers I'll be conducting different discussions to discuss all past papers. In 25 also I discussed few past paper discussions. Some of them are still on my YouTube channel. So likewise, for past papers for 27, 26, for all batches, I'll be conducting those discussions separately for the past papers, right? And in my class, here what you are writing is model questions and target questions exam standard papers, and these questions are, I mean, these questions are the ones that that is made by me, right? Me, in the sense, there are some sources I'm taking questions from, books, papers, questions. Some are term test questions, question term test question type question they are target questions. That's why, right? So therefore, it will be going parallel with the point that you have covered in the theory class, right? So therefore, now since we are starting the first paper next week, right? Since you are starting the first paper next week, please go through everything from the beginning up to this point and get ready, right? Since you have to write the paper next week, right? Go through everything and get ready yourself, prepare yourself for the discussion, right? For the writing, not the discussion first, for the writing part first, right? දැන් මොකුත්ම නැතුව ක්ලාස් එකට එන්න එපා පේපර් එක ලියන්න. ඒතකොට ඉතින් මතක නැත්තම් බලාගෙන ඉන්න වෙන්නේ, right? So therefore, go through everything and be comfortable, and if you got any doubts, any clarifications needed from my side from the previous lessons we have covered, you can contact me in a free time, and try to be comfortable and practice all the questions we did in the class especially. And now in new tutes, all the past papers are already given at the back of the tute, so you can try the past papers as well with the answers. Okay, answers තිබ්බද මේ center of gravity එකේ? Was it there? Last page? Last page. No? Oh, okay. If the answers for center of gravity paper, center of gravity tute is not given, I'll upload those answers separately, right? And for the other tutes you are getting, I mean, for friction one also, it is with the answers, right? It is with the answers, even for the friction. And I didn't post any tutes this week because of the condition in the country, and you will be getting all the tutes by the next week. By the next week means now by tomorrow, by Sunday, I'll be posting. I didn't post the tutes intentionally because for some areas still there are things happening around and there are delays in deliveries, right? Give me 1 minute. Right, so there were delays in the deliveries, so that's why intentionally I didn't post the tutes last week, right? Personally also I experienced මේ මම pens වගේක් delivery එකක් දාලා තිබ්බා. මේ pens දෙකක්, මේ pens ටික ආවෙත් එන්දරලා පරක්කු වෙලා. يعني එහෙම එකක් තිබ්බ. ඒ කියන්නේ මේවා couriers, even if that's a courier, පොඩි delays තියෙනවා ඉතින්. දැන් මෙහෙ එච්චර affect වෙච්ච නැති area එකක්නේ. But for affected areas, those things are still there, right? So that's why I didn't post, because if that got misplaced, no one is going to get the tute. I have posted, but if you didn't get the tute, there's no point of sending it, no? අපරාධනේ. Right? ඒක දැම්ම නැත්තේ. මේ by next week, before the next class, before next class, in 2 to 3 days, you will be getting it. All right then. Any other questions before starting? Any other questions before starting? And is there anyone except you who are unavailable during this time? Initially, you are doing both writing and discussion on the same day. Initially, right? Then at some point, you will be getting a different date for writing and a different date for the discussion. Not sooner. ඒකට around 6 months වගේ. ඒ කියන්නේ දැන් 26 අයට දැන් එහෙමයි යන්නේ. ඒතර ඕගොල්ලන්ටත් ඒ වගේ එකක් වෙනවා. තව ඒ කියන්නේ when enough number of lessons and units are covered. يعني තාම පොඩි paper එකක් නෙමෙයි යන්නේ. around 1 hour වගේ paper එකක් නේ. ඒතර දැන් paper එක අපි අර structure එකට ආවට පස්සේ අර විදිහට මම ලියන්න ගන්නවා. Because now still what you are getting is 25 MCQs with 2 essays. ඔයගලන්ට term test දැනට යන paper එකේ structure එක. ඊට පස්සේ යන්නේ 50 MCQs, 4 structured essays and 8 මේ 4 structured essays and 8 essays. ඒක තමයි exam standard paper එක. අන්න එහෙම වෙද්දි මම separate day එකක් දානවා writing වලට. both. ඔය දැන් එහා පැත්තේ කෙනෙක් ලියන්නේ මේ 26 class එකේ paper writing එක. මෙතන හිටියේ here and හොරණ දෙකේම තියෙනවා. institutes දෙකේම තියෙනවා. institutes දෙකේම තියෙනවා. දැන් මේක ඔලුවට දාගන්න එපා. that is going to come after like 6-7 months. say 6 months ඒ වගේ. එතකොට මම institutes දෙකේම මේ dates ඔයගොල්ලන්ට කියන්නම් මොනවද writing dates කියලා. you can come here. You can ask the paper from the office and write the paper and hand it over to them and you can leave. Right? ඊට මම එක දවසක papers ටික collect කරගන්නවා and you will be getting the graded paper on the date of discussion. Right? That's the ultimate plan. Okay. දැනට 26 එකේ යන plan එක ඒක. ඒගොල්ලොත් මුලින් in class writing කරා. දැන් මේ ඔයගොල්ලන්ගේ in class writing එක. ඊට පස්සේ දැන් in class writing එකෙන් once you get the experience, once you have enough practice, you can write the papers on a separate day as 26 batch is doing. Right? එහෙම එකකට එනවා. So until then I have to practice you writing questions with you and I need to make sure that you all are confident enough to write the papers independently. That's why. ඒක එකපාර කරන්න බෑනේ. It takes some time. That's why. Right? එතකොට මේ ඉන්ස්ටිටියුට් එකට එන කට්ටිය මේක ලියන්න පුළුවන්. කරන ලීසා එකේ කට්ටියට ඒක ලියන්න පුළුවන්. ඔන්ලයින් කට්ටියට ඔන්ලයින් ලියන්නත් පුළුවන්. And all the papers will be marked. Right? Online එකත් same website එකට ගිහිල්ලා ලියන්න පුළුවන්. All right. So when we write papers, it is physical or online. Both are there. So when separate days for paper writing is given as your preference, you can either write it as an online one or a physical paper. Right? Okay. That's all. Right. Let's start. Now, today we are starting friction. Now we are eventually moving towards the latter parts of mechanics, right? And the parts coming up are friction, rotational motion, circular motion, hydrostatics, and hydrodynamics, right? Those are the remaining parts in mechanics, and today we are starting friction, right? So when it comes to friction, in terms of the gravity, friction is very much involved in mechanics questions that is going to come up in the future, and that is going to connect with the question types you have already discussed in Newton's laws, right? Very easily it can be connected, and there are links, there are connections, right? Connections links so therefore, as a lesson, even though friction is a small lesson, that is actually a small lesson, even though friction is a small lesson, the connections of friction with the other parts are very much higher, right? So therefore, this is also a very significant lesson we have, a chapter we have in our lineup, right? Okay, put the heading as friction. Put the heading as friction. Okay, when I say friction, what's the idea you have about the force friction? What is the idea you have about the force friction? What's the current idea you have? Anything? Not the definitions. What's the idea you have about friction? Traction. Texture. Huh? Tension. Tension between two surfaces. What else? Just tell me your thoughts. That's it. For online ones also, the question is open, right? And I can see both chat boxes, Zoom and YouTube. Anyone can answer. What else? Friction. To keep us keeping on the same place without moving. Minor barrier to object in motion. That's a kind of a good one. Resisting motion. That's also a good one. Now, some words are coming. Good. Yes. Now, I'm going to collate all the things that you said and going to introduce friction. Listen, friction is something like this. Friction is something like this. First idea about friction is a resistive force. There is a resistance. There is a barrier. That is correct. There is resistance. There is a resistive force. Right? Since there is a resistive force, the next main feature in friction is acting always opposite to what? Opposite to motion, because there is a resistance. Resistance is a disturbance. Resistance means there is a disturbance. There is a disturbance force. Therefore, that is opposite to motion if there is a motion. If there is no motion, if there is only a moving tendency for an object, right? I'll show you what a moving tendency is. If there is only a moving tendency for a motion, still there is friction to the opposite direction of motion, opposite direction of motion tendency or moving tendency, right? That force is called friction, and friction is due to the contact between two surfaces, and friction is acting along the surface only, along the surface, right? So those are the features of friction force. Now we are going to discuss, right? First, write down in red. Write down in red with an asterisk mark. Write down in red with an asterisk mark. Write down with an asterisk mark. Friction force. Friction force. Friction force is a resistive force. Resistive force is a keyword. Resistive force. Friction force is a resistive. Friction force is a resistive force. Resistive force. Acting in opposite direction to acting in opposite direction to acting in opposite direction, right? So this is under keyword. I'm mentioning the keywords here. Opposite direction to motion, opposite direction to motion, or opposite direction to motion, or tendency of motion, opposite direction of motion or tendency of motion, opposite direction of motion or tendency of motion, opposite direction of motion or tendency of motion of an object. Right? Listen. Now here I explain about two words. One is motion. That you already know what a motion is. And the other word is tendency of motion. Tendency of motion. Tendency of motion means, is there a motion? No. There's no motion. Right? Tendency of motion means there's no motion. There's no motion. There is only a tendency of motion. As an example, look at here. Say this one is given. This one is say given a force and the system is accelerated, right? System is accelerated, so that is simply a motion, right? And here say no force is given for the object, no force is given for the object, and that is kept on a surface like this, kept on a surface like this, right? Now there's no motion here. Here there is a motion. See, this thing moves, so therefore this is a motion, this is a motion. Here there's no motion, there's no motion as well, there's no moving tendency. there's no moving tendency. There's no motion and there's no moving tendency. And if I keep another object on a plane like this, if we can keep another object on a plane like this, right, in equilibrium, is there a motion now? No, still there is no motion if there is an equilibrium, because this is rough, right? Still no motion. But in such a case, there's a moving tendency. There's a moving tendency in which direction? Downwards, right? There's a moving tendency downwards, moving tendency, downwards moving tendency. If the object is at rest, there can be both, because both are at rest. No acceleration in both. See, here also there is no acceleration. In this scenario also there is no acceleration, right? But now if I keep this, say this one. Now if I keep this on a horizontal plane like this, there's no motion and there's no moving tendency. But if there is on an inclined plane, there is a moving tendency, but that is still at the rest. There's a moving tendency. If this angle is inclined further, see, it starts moving. So that is the moving tendency. There's a moving tendency downwards because of exactly mg sine theta. Because when mg acts this way, mg sine theta acts downwards. So with that mg sine theta, it creates a moving tendency. There's a possibility of movement. There is no possibility at all. There's no possibility at all. Forces on mark kala pennana. Right? Forces mark karot mehe ekak wenne. Here, if I mark mg acts this way. Doesn't support the motion. Doesn't support the lateral motion. But here, mg acts like this. If this is theta, this mg sine theta is going to create that moving tendency. Downward force, so it's going to create the moving tendency. So therefore, this is an object, this is a system with a moving tendency. Right? Now here, since there is no moving tendency and no motion, there's no friction. But here, since there is no motion but there is a moving tendency, there's friction. That is how this mg sine theta is counterbalanced. Now from equilibrium, you know, there's no motion, forces should be balanced. ඒක තමයි අපි equilibrium friction වලින් කරලා ආවේ. Right? From equilibrium that we know. If there is no motion, right, forces should be counterbalanced. Then there should be someone to balance this mg sine theta. That is friction. Friction is playing the role here. Right? Okay. Now take this down. Two things. Motion is just the motion that you know, it is accelerating. Right? It is accelerating. Take down. Here, I'll add this point, friction acts. Right? Friction acts. Now friction එක mark කරන්න like this. We use simple F when marking friction. Right? Here, no friction. Here, no friction. And here also, friction acts. Friction acts. And this is how friction acts. So there are more things to look at, right? That's coming up in the coming parts. Write down. Right? This is a motion, so friction acts. This is a motion, friction acts. And this is about the tendency of motion. About the tendency of motion. In such a case, since there is no motion and no moving tendency, there is no friction. Right? That's the definition of friction. No? When there is a motion or moving tendency, friction acts. Right? When there is a motion or moving tendency, friction acts. Now, in this case, there is a motion, friction acts. In this case, there is a moving tendency. See, there is a moving tendency. There is a moving tendency, so friction acts. So, in this case, there is a motion, so friction acts. Right? Write down below with a red pen. Write down below with a red pen. Put an asterisk mark again. Right? Below all diagrams. Huh? Below all diagrams. Write down below with a red pen. Put an asterisk mark again. And write down friction acts. Friction acts. Friction force acts. Friction force acts. Friction force acts. Along the contacting surface. Friction force acts along. Friction force acts along the contacting surface. Friction force acts along the contacting surface. Within brackets, parallel to contacting surface. Parallel to contacting surface. Right? It's clear, right? Next. You got the board. Then tell me, does friction act on objects at rest? Yes, yes. That is the exact thing we discussed here. Right? Friction acts on objects at rest. If there is a moving tendency, rest again, but there is a moving tendency. If there is a moving tendency, it acts. Right? That is how it acts. Okay. Then, listen. Now, basically we have two types of surfaces here. You already know. One is smooth and the other one is rough. Right? A smooth surface means even if there is magnified any number of times, right, you will see exact even, right, exact even surfaces. That is what is meant by smooth. There is no any unevenness in the surface, no unevenness at all, right? There are smooth surface එකක් කියන එක තියෙන්නේ මේ වගේ. ඒතර අල්ලලා බලලා smooth කියලා කියන්න බෑ. right? ඒ කියන්නේ එහෙම කියන්න පුළුවන් for some extent. ඒකයි smooth rough කියලා 100% smooth කියන එකක් මේක කියන්න බෑ. right? මේ magnify කරත් මේ වගේ තමයි smooth surface එකක් වෙන්නේ. like this. Now even though that is magnified, this is how a smooth surface look like. There's no 100% smooth surfaces in real world. That is an ideal scenario. Ideal scenarios කියන ඒවා අහලා තියෙනවනේ. Ideal gases පටන් ගන්න තියෙන in chemistry. Ideal gases, ideal scenarios. Ideal means there is a hypothetical scenario. There is a hypothetical scenario. So therefore, in real world, you can't find any 100% smooth surfaces, right? එහෙම තියනවා කියලා හිතා ඉන්නවා නම් එහෙම නැහැ. right? කියන්නේ මොනවද අර තියෙන්නේ? ඇඩ්ස් වලත් සමහරලාවට යනවා. මොනවද අර මේ ඇඩ්ස් වල lotion මොනවද? ඇඩ්ස් වල යන්නේ? smooth skin ගන්න අරම there are no 100% smooth skins. There are no 100% smooth surfaces in the real world. That's a hypothetical scenario. That is an ideal scenario. Right? So ඇඩ්ස් වල යනවා. ඒකට එහෙම ඒවා නැහැ. right? ඔච්චර කරත් පෙටල් එකක් ගත්තත් මේ මොනව ගත්තත් that is for some extent it has friction. Right? It has a roughness. Friction කියලා කියන්න ඕනේ නැහැ. It has a roughness. Smooth ඒවා කියලා නැහැ. Right? Maybe a very minimum value. It changes, but that is not zero. Not zero. Right? මෙහෙම තමයි smooth surface එක තියෙන්නේ. And this is another smooth surface. See? And here this smooth surface is going to be dragged on another smooth surface. Right? මම මේක 1 කියලා දාන්නම්කෝ. Scenario 1. This smooth surface is dragged on another smooth surface. And this one, scenario 2. Scenario 2. This is a smooth surface. Look at the board. This is a smooth surface. And this smooth surface is going to be dragged on a rough surface. If you get a zoomed view, a magnified view of a rough surface, this is how a rough surface look like. If you get a magnified view, there is an unevenness. Right? Say this whiteboard. Now, just for the naked eye, it feels like and it seems like it's smooth. This is not smooth. Make a 20,000 times වගේ සාමාන්‍යයෙන් අපි මෙහෙම magnify කරලා බලුවොත් මේක මේ unevenness පේන්න ගන්නවා. 20,000 times වගේ. That is uneven. පේන්නේ නැහැ. In a very micro level, that is uneven. So therefore, this is how a rough surface look like if there is magnified. This is how a rough surface look like. සමහර rough surfaces අපිට නිකන් බලන්නත් පුළුවන් මේ walls එහෙම. මේ wall එකේ නම් මේක it can be felt නේ. Can be felt. මේවත් සමහරව තියෙනවා. සමහරවල් අතර smooth වගේ තේරෙනවාට අතර මේවා smooth නෑ මොකද? Then in this scenario, two rough surfaces. See? Two rough surfaces. Like this. Two rough surfaces. Rough and rough. Right. Now, in all scenarios, this is going to be dragged. Right. See? Now, we are going to see in which cases friction is going to occur. Right? Now tell me, if they are smooth and smooth, what do you think? Is there any friction in between? Now these are in contact. I have kept an space intentionally to mark forces. To mark forces. That purpose is marking forces. What about the smooth case? Is there friction? No friction. There's no friction. So I'll mention it here. Here there is no friction. Here there is no friction. There is no friction. This case, smooth and rough. What about friction? No. There. Online. What about friction? In second scenario, quickly. Smooth and rough. What about the friction between a smooth and a rough surface? What do you think? Is there a friction? No, not. That's my question. Quickly. Why G is acting sideways? Friction acts. Wait. Why G is acting sideways in the previous diagram? That is not sideways. Mg is acting at the center of gravity. Center of gravity. Right? Friction acts. Others? What do you think? What do you think? Friction acts. Here also, there's no friction acts. There's no friction acts. The reason is this. The reason is this. You can see the reason. The reason is now still this smooth surface is slip. This is completely slip on the rough surface. It is slip. So therefore it's slipping. There is no friction. But even though there is an unevenness in the rough surface, this is smooth now. So it slips. No friction. You will understand this better once I explain this one. If that is rough and rough, what happens is these ones are these small uneven particles are going to go in from either side, and then it's going to create this resistive force. Can be resistive force second then apart out of nowhere it is not going to come no. This is how it is going to create. When it contacts with the other surface, when these uneven sides are going parallel to each side, then it creates this disturbance. It creates this resistive force. Correct? Right. Now? This one. Yeah. So we have yes. So if it's more than a point, no. Still that is going to move. Say you are moving a rough particle on a smooth plane, that is never going to stop. There's no friction. Right. Maybe particle is rough. If your surface is smooth, there's still no friction. So therefore, this is one of the main things main points we are starting friction in order to act friction, because the reason to explain this way is because most of the students are messing this up with this scenario. But most of you are messing this up with this scenario, right? So therefore, I want to highlight this. Friction acts only between two rough surfaces. Even if one surface is smooth, it results in zero friction. Even if one surface is smooth, it results in zero friction. Therefore, friction is only between two rough surfaces. Right? Only between two rough surfaces. Take it down. Air drag. Same. Same. MG, suppose. No? Okay. Then? No, that is perpendicular to this motion. Right? Perpendicular. Take it down. So very important, there's no friction here, no friction here, and friction acts only here, which means having two rough surfaces is mandatory, is compulsory to have friction. And just know that smooth surfaces are an ideal scenario. That is an ideal scenario, a hypothetical scenario that doesn't really exist in the real world. Finished? Write down below with a red pen. Write down below with a red pen. Put an asterisk mark again and write down friction acts only between friction acts only between friction acts only between friction acts only between two rough surfaces. Friction acts only between two rough surfaces. Friction acts only between two rough surfaces. Right. Right. Next heading, write down equation of friction. Next heading, equation of friction. Equation of friction. Equation of friction. Right. Equation of friction is F equals mu R. Equation of friction is F equals mu R. Right? We denote friction by symbol F. Equation is F equals mu R, where F is frictional force. F is frictional force. Mu is, anyone? Mu is coefficient of friction. Coefficient of friction. Coefficient of friction is a constant for the surfaces that is in contact at the moment. Right? Coefficient of friction. It determines nature of the surface, or we can say mu determines roughness of the surface. Right? There is a value that determines the roughness of the surface, and mu varies between, no need to write this now, mu varies between 0 and 1. Right? More towards one side means more towards the rougher side. More towards 0 side means more towards the smoother side. Right? So that's a value, that's a constant between 0 and 1. Got it? And R, what is R? R, perpendicular reaction. Perpendicular reaction is R leave a perpendicular reaction like that. Perpendicular reaction, a normal reaction, perpendicular reaction. Right, take it down and highlight the equation. Don't write this now, that I'll give you in the note separately. F equals mu R. F equals mu R. %, rough? No. In between. In between. So that is why mu is not equal to 0 or 1. Right? Mu is not equal to 0 or 1. All extreme ends are hypothetical scenarios. Yeah. Rough. For water, for not only for water, for any liquid also there is a friction. Right? Now in mechanics, under mechanics, we are discussing about the friction in solids. Right? There is a separate lesson coming up as viscosity in unit 7. Right? Unit 7, viscosity, about liquid friction. In all solid, liquid, gas mediums, there is friction. In mechanics, I mean, in this part, you are discussing about the friction in solids only. But in the syllabus, we have both. Yeah, because that reduces roughness, not come in 0, reduces only. Yeah, it's true. Any liquid is comparatively smooth compared to solid. Any oil, any liquid, but that doesn't mean there's no friction. Still there's friction. The thing is, compared to a rough surface, that will become a little bit, I mean, it will move towards the smoother side, but still there's friction. That is called liquid friction. Right? Liquid friction eකට example එකක් කියන්නම් ඕන ආපු නිසා liquid friction determines thickness of a liquid. Now as an example, now if this is water, now when we pour this, right, very instantly it's pouring now. So what if this bottle was filled with treacle or something, treacle, honey, so it takes some time to pour. That is because the thickness is high, and that is because of the friction between the molecules in honey, treacle is high. Yes. Higher. Yeah, you can compare. Yeah. They varies. It varies. It varies. That is what we call the thickness of a liquid. Not the density, thickness. Density and thickness are two different things. Right? Okay. F frictional force. F frictional force. F frictional force. Mu coefficient of friction. Coefficient of friction. R perpendicular reaction. Perpendicular reaction. Perpendicular reaction. Okay, write down below. Mu determines. This is a symbol, this is a Greek symbol. Mu liyanne epa nikan capital M wage, right? Mu liyanne mehemai. One line here with this mu. This is called mu. Mehemai liyanne. Mu neme mu. That is called mu. So does zero mean smooth surface? Yeah, zero means smooth, but there are no smooth surfaces. Yes. This one. Oh, may uppercase. Right? Okay, write down below. Mu determines the nature of the surface. Mu determines the nature. Mu determines the nature of the surface. Mu determines the nature of the surface. Right? Next point, keep using red. Mu is a value between 0 and 1. Mu is a value between 0 and 1. Okay, take this down again. Take this down now. Mu is a value between 0 and 1. Mu is a value between 0 and 1. Right? Okay. Now, a small task. Listen. Find units and dimensions of mu. 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 What are the units? Then units. Units? Huh? No units. Online? What are units? Then what are the dimensions? ml squared t minus 2 ml squared t minus 2. Others? Quickly. Now you have already done units and dimensions, right? Units and dimensions कर लेते हैं. मैं क्यों करते हैं? The equation is f equals mu r. Then mu is given by f over r. Then units of f over units of r. Units of f. This is a frictional force measured in newtons. Units of reaction. Reaction is a force measured in newtons, right? Which means 1. 1 means unitless. 1 means unitless. No units. Unitless, right? And for dimensions, dimensions of force over frictional force over dimensions of perpendicular reaction. Both are forces, so it cancels off. This is mlt minus 2, no? This is also mlt minus 2. Cancels off and it becomes 1. 1 means dimensionless. Dimensionless. Right? So therefore, mu is unitless and dimensionless. This is a coefficient, a number. Make a number between 0 and 1. There is a value between 0 and 1. Right? So that is unitless and dimensionless. Both unitless and dimensionless. Right? Write down below again with a red pen. Mu is both unitless. Mu is both unitless. Mu is both unitless and dimensionless. Mu is both unitless and dimensionless. Mu is both unitless and dimensionless. Both unitless and dimensionless. Okay. Next. Listen. Now we know that friction acts on both moving and unmoving objects, right? On both moving and unmoving objects. Friction acts on both. So therefore, if friction acts on a moving object, let's say non-moving, if friction acts on a non-moving object, look at the board. If friction acts on a non-moving object, that is called a static friction. Static means no motion, static, right? So if friction acts on a moving object, if friction acts on a moving object, that is called dynamic. That is called dynamic, or it is also called kinetic. Right? Don't write. So if there is acting on non-moving, it is called static. Right? If there is acting on moving, that is called dynamic or kinetic friction. Right? Yeah, it's coming now. 5 minutes. Right. Next point. Keep using red. Next point. Keep using red. Friction acts on both. Friction acts on both. Friction acts on both. Friction acts on both moving and both moving within brackets static, sorry, both moving within brackets dynamic and kinetic. Friction acts on both moving within brackets dynamic / kinetic and non-moving and non-moving within brackets static and non-moving within brackets static objects. Static objects. Right. Next thing. Now about this, we already discussed at the beginning also. Now again, we are going to compare these two scenarios. Look at here. And before the diagram, write this down. Write down again using the red pen. Write down again using the red pen. Even if there's no motion for an object, 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 having a moving tendency, having a moving tendency, having a moving tendency is enough, having a moving tendency is enough for friction to act. Having a moving tendency is enough for friction to act. Having a moving tendency is enough for friction to act. Right. So let's compare these two scenarios. Now both are rough surfaces. But if there is no force to create at least a moving tendency, right? Now here there is no motion, and there's no moving tendency as well. Because if you just check the direction of mg acts vertically downwards, right? No contribution for this motion. But in this case, let's say this angle is theta, this is a rough surface, right? Rough surface. Now mg acts from the center of gravity like this, right? So if you extend this, this angle is again going to be theta, and this component is mg cos theta, whereas this component is mg sin theta. Now mg sin theta creates the moving tendency. Since mg sin theta creates a moving tendency, friction is coming to the play now. That is coming to play. That is going to play the role, right? Since there is a moving tendency, friction acts at the contacting surface to the opposite direction like this. Acts at the contacting surface to the opposite direction like this, right? Take these two, and we'll be writing few points below each side, right? Keep some space below to write few points. And here also there's no motion, A equals 0. Here also there's no motion, acceleration equals 0, which means both systems are at equilibrium. Both are at equilibrium. No motion. But only this one is having a moving tendency. No motion. So doesn't friction only act on non-moving objects if there is a moving tendency? Friction only act on non-moving objects if there is a moving tendency. Yes, that is exactly what I explained before this diagram. Right? Okay. Right down below. First point here, this side. Right? Not the asterisk mark, bullet point. First bullet, write down, no motion. First point, no motion. No motion. Second point, second point, second point, no moving tendency. No moving tendency. No moving tendency. No moving tendency due to, no moving tendency due to, below the first diagram, no moving tendency due to no force acting, due to no force acting along the plane, due to no force acting, due to no force acting along the plane, due to no force acting along the plane. Third point, therefore, no friction, therefore, no friction, therefore, no friction, no friction. Right? This side, first point, no motion, no motion. Second point, there is a moving tendency, there is a moving tendency, there is a moving tendency, there is a moving tendency along the plane, there is a moving tendency along the plane, there is a moving tendency along the plane due to mg sin theta, due to this one, due to mg sin theta. There is a moving tendency along the plane due to mg sin theta. Right? Next point, next point. Therefore, friction acts, therefore, friction acts opposite to, finished. Therefore, friction acts opposite to moving tendency. Right? What did I say? I finished the sentence. Okay, so therefore friction acts opposite to moving tendency. Right? Friction acts opposite to moving tendency. Right. Now you should understand this better. The question, sir, can upward friction just be called upward friction? Upward friction, you mean this one? Upward friction just be called a normal reaction force? No. No. What's the definition of a normal reaction? It is normal, right? First day of Newton's laws. A normal reaction is a perpendicular reaction, right? So first day of Newton's laws. This is not a normal reaction. This is parallel. This is a parallel force. right? Okay. Next point. Next point. Write down. Friction has two main types. Friction has not a red pen, not a red pen. Friction has two main types. Use your normal color. Friction has two main types. Friction has two main types. Friction has two main types. Right. We know friction acts on both moving and non-moving objects. Right. So therefore, if the friction acts on a non-moving object, right, that is called a static friction. It makes sense, no? Non-moving means static. So therefore, that friction is called static friction. Static friction is on non-moving objects. And if the friction acts on a moving object, that is called dynamic friction or kinetic friction. Dynamic or kinetic friction on moving objects. Right? Write down number one, a static friction. A static friction. A static friction within brackets on non-moving. Static friction within brackets on non-moving objects. On non-moving objects. Number two, dynamic friction. Number two, dynamic friction. Dynamic slash kinetic, right? Both. Dynamic, most popular word is dynamic, right? So that's why I'm always saying it's dynamic. Most popular word is dynamic. That is also called kinetic, right? Dynamic or kinetic friction within brackets on moving objects. On moving objects. Right. Next heading. Next heading. As a next heading, write down definition of coefficient of static friction. 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 Okay, listen now. Listen. So we know general equation of any friction is F equals mu r, right? If there is about a static scenario, we can specify this as F static, and accordingly, this is considered as mu static, mu s into r. If we are to define mu, we have to subject mu, no? Right? Subject mu from this. Mu s is Fs over r, right? Using this ratio, now we are going to define this, right? So in definitions, there are few rules, basic rules behind that we already know, right? If both numerator and denominator are same in dimensions, that is defined as a ratio, right? Or if they are having different dimensions, always the denominator term is made one unit terms, right? If something is divided by time, that is defined as a rate. Basics, right? As an example, definition of velocity is rate of change of displacement. Velocity, rate of change of displacement. Rate means that is over time, right? Another example is, say, rho equals m of v. Rho equals m of v. Mass per unit volume is defined as density. Mass per unit volume. Different dimensions, no? Then denominator terms are made one unit terms. But here they have same dimensions. If it has same dimensions, they are defined as, such quantities are defined as ratios. So therefore, this is a ratio between static frictional force and perpendicular reaction, no? This is a ratio between static frictional force and perpendicular reaction, right? And very importantly, listen, very importantly, this mu s, static mu, is defined at the very point where the object starts motion. At the very point where the object starts motion. The reason is this, right? I'm going to explain this a bit now for the definition because more explanations are coming up about this. Now, even though force is applied, this is not moving now. Up to some extent, even if this force is increased, this is not moving yet. At some point only, it starts motion. So therefore, there are more points in static region that we can't identify as a single point, because when we change the force, friction also changes. If I touch this, let's say now the applied force is 1 Newton, and if I increase a bit, still that is at rest. Right? Right? If I increase another bit, still at rest. At one point it goes. Right? So therefore, there are infinite static points for an object, for a given object. There are infinite static points for a given object. There are infinite static points. Right? But when we are doing a definition, we have to do the definition for a single point. So therefore, since that moving point, the starting moving point, is identifiable, definition is done for that point, because all other points cannot be observed experimentally. But the moving point can be seen experimentally. Moving point is the very last point of static friction. No? Therefore, this definition is only valid for the last point of static friction. That is also called limiting friction. That is also called limiting friction. Right? Very last point of a static friction, or in other words, there is a maximum value of static friction. Got it? Okay. Start from here and right up to here. Now, after the definition, there are more things coming up about this. Right? Okay. Take down the definition in red. Take down the definition in red. Now you are going to define this. Write down. When an increasing force, when an increasing force is applied on, when an increasing force is applied on an object, when an increasing force is applied on an object at rest, when an increasing force is applied on an object at rest, the ratio between, put a comma, at rest, put a comma and keep writing, the ratio between static friction, the ratio between static friction and perpendicular reaction, the ratio between static friction and perpendicular reaction, when there's a moving tendency, is defined as, coefficient of static friction, is defined as coefficient of static friction, right? Now, as we define the coefficient of static friction, now we are going to define the coefficient of dynamic friction. Right? That is also called dynamic coefficient of friction. coefficient of static friction or static coefficient of friction. Both are fine. So coefficient of dynamic friction or dynamic coefficient of friction. Next heading, write down definition of coefficient of dynamic friction. Definition of coefficient of dynamic friction. Definition of coefficient of dynamic friction. Right. Again, F equals mu R. Right? If there is dynamic, we can specify this as Fd and mu d R. Right? If you need mu d is Fd over R. Right? Dynamic means there is a moving object. Same thing, same idea. The ratio between dynamic friction and perpendicular reaction of a moving object is defined as dynamic coefficient of friction. Right? Write down. Very comparative. Same thing. Okay. Write down the definition again in red. Write down the definition in red. The ratio between dynamic friction, the ratio between dynamic friction and perpendicular reaction, the ratio between dynamic friction and perpendicular reaction, dynamic friction and perpendicular reaction on a moving object, on a moving object, on a moving object is defined as, on a moving object is defined as coefficient of, is defined as coefficient of dynamic friction, is defined as coefficient of dynamic friction, is defined as coefficient of dynamic friction. Right. Listen now. Listen. Experimentally, it is found that, listen, experimentally, it is found that mu d is always less than mu s. We can feel this practically. Mu d is always less than mu s. Mu s is higher. Now, as an example, let's say you are trying to push a table on the floor, right? You are trying to push a table on the floor, right? So until it starts the motion, you have to put some more effort than compared to what happens if it starts the motion, right? Push කරලා බලන්න නිකන් මොකක් හරි ගෙදර තියෙන එක තල්ලු කරලා බලන්න. Until it starts the motion, right? We can feel it. You can feel it that you are applying more force compared to the force you are applying once it starts the motion. Right? ඒ වගේ scenario එකක්. තව නිකන් example එකක් කිව්වොත් දන්නවා නම් boys should know, if you have pushed breakdown vehicles, breakdown වෙච්ච vehicle එකක් කළා තියෙනවා නම්, until we start the motion of the vehicle, we have to put more effort. But once it started, the effort is less. Right? ඒකත් එහෙම එකක්. Right? මොකුත් ඕනේ නැහැ මේ නිකන් ඔය තියෙන මොනවා හරි මූ කරලා බලන්න. මොනවා හරි මූ කරලා බලන්න. Once it starts the motion, right? We can apply a small force compared to the applied force before to start motion. Right? ඔය ගෙදරදී ඔක බලන්න පුළුවන්. Once you play around with the chairs, tables, and everything when you are cleaning the home, cleaning your house, right? You can feel it. This is experimentally proved, but practically also we can feel it. So therefore, for any object, mu s is greater than mu d. Mu s is greater. Always static friction is greater. Right? Write down below with a red pen again, with an asterisk mark. Put an asterisk mark with red. put an asterisk mark in red and write down always mu s is always mu s is greater than mu d for any given surface always mu s is greater than mu d for any given surface. Always mu s is greater than mu d for any given surface. Take this down and highlight. Take this down and highlight. Right, take down and highlight. Next heading. Sorry. Friction loss. Friction loss. Friction loss. Right. So there are 4 laws regarding friction, and some of the laws you already know because of the discussion we had, because of the explanations I had before as well. Now we are going to list down everything as follows here. There are only 4 laws regarding friction, right? Usually laws won't be asked to write, but the thing is, when it comes to a question, when it comes to an application, all 4 laws are used in the application. So therefore, without knowing these laws, you can't do the questions. That's the thing. Otherwise, now in the history, right? In the history, laws are not questioned as to write as laws. Because once a question came, all 4 laws are used inside. So therefore, if someone doesn't know the laws, which means that particular person is not able to do that question. So therefore, usually these laws won't be asked to write. It won't be asked to write as a law, right? But instead, it will be used in each and every application. Some you are doing in friction, right? So first we will mention all laws. First one, write down. First law is about the direction. Write down. Friction acts. Use the normal color. Friction acts in opposite direction to friction acts in opposite direction to friction acts in opposite direction to motion or moving tendency. Opposite direction to motion or moving tendency. Opposite direction to motion or moving tendency, right? Second law is about the dependence of friction. See, so we know F equals mu r, no? Since F equals mu r, friction depends on mu n r, no? Since F equals mu r, friction depends on mu n r. Mu depends on what? Mu depends on nature of surface. Roughness of surface. Nature. That is called the nature of surface. So mu depends on nature of surface. I mentioned this word before. This depends on nature of surface or roughness of surface. R is perpendicular reaction. So therefore, friction depends only on nature of surface and perpendicular reaction. Most importantly, friction is independent of contacting area. Friction is independent of area. Friction is independent of contacting area. Area right? Okay. Second one, write down, second law. Friction depends on, write down. Friction depends on nature of the surface. Friction depends on nature of the surface. Logic එක තියෙන්නේ මෙතන. Friction depends on these two. Friction depends on nature of surface and perpendicular reaction. And perpendicular reaction. Friction depends on nature of surface and perpendicular reaction. Only. Friction depends on nature of surface and perpendicular reaction only. And friction is independent of. And friction is independent of, for the same law. And friction is independent of. And friction is independent of area of. Friction is independent of area of contact in surface. Friction is independent of area of contact in surface. Independent of area of contact in surface. Right. If needed, you can write this within brackets, right? If needed, because dependents are in the equation itself, right? Area is not a dependent. Third one is a very important and very much used law when it comes to our questions. Listen. Something like this. For the third one, I'll explain a bit before I give the law. What do we have today? See, this one is better. I think it cannot be seen by the online students. Any other heavy objects? No. No. Right. See. Is it visible to the camera? No. Oh. Okay, see. Camera එක නැත්තයි අතේ තියලා මේ කැමරා එකට පේන්නේ නැත්නම් අතේ තියලා තමයි කියලා දෙන්න. Okay, look at here. Say this is a horizontal surface, right? This is better. Say this is a horizontal surface, right? This is a horizontal surface, and this object. Oh, the object and okay, let's take this one. This object is kept on this. This object is kept on this surface. This is a horizontal surface, and on this horizontal surface, this object is kept, right? Now, if there's no force is applied, listen, this is the most important part here we have in friction. If this part is understood, 50% of the friction is done. This is the most important part, and the part where you have to understand properly is here, right? Heavy muddy. See, let's see. Right. Now, if this is kept, this one, if this is kept on this horizontal surface, right? Tell me, is there a motion? Is there a moving tendency? No. Is there a friction? No. If there is no motion or no moving tendency, no friction, right? Now, I'm going to apply a force on this. Now, At the very point that I am touching this, a force is applied. No, we are touching means there's a reaction between my finger and this object, right? So which means the force is acting. The force is acting, right? Now just assume that the force I have applied at this point as 1 Newton, 1 Newton, right? Now when I have applied 1 Newton, is it moving? Is it moving now? No. Is there a moving tendency? Yes. Because now I am pushing this with a force of 1 Newton to the right. See, I am pushing this with a force of 1 Newton to the right. But there is no motion in the object, which means my 1 Newton force is counteracted by or counterbalanced by someone else. No? Because you know F equals ma. If there is an unbalanced force, there should be an acceleration. If there is no acceleration, if there is an equilibrium, which means forces are balanced. Forces are balanced now. Forces are balanced. Then when I apply 1 Newtons, if there is no motion, which means someone else is counterbalancing my applied 1 Newton. There is none other than friction. There is friction. So therefore, now imagine friction. Friction acts opposite to my moving tendency, which means friction acts in leftward direction along the surface, parallel to the surface, like this, right? Now, what I am trying to do is, listen, what I am trying to do is going to increase this force up to 2 Newtons. Let's say I am increasing this force up to 2 Newtons. Still there is no motion, no? Still there is no motion, which means friction has adjusted to 2 Newtons, no? Isn't it? If friction was at 1 Newton, now if when I apply 2 Newtons, there should be a remaining unbalanced force. But still, there is no motion even if my force is increased, which means friction has adjusted. Friction has adjusted. You can try this out. No? You can try this out. Friction has adjusted. Again, if I increase the force further, still it is at rest. No, weight is perpendicular. No, no contribution. No contribution at all, because moving tendency is horizontal here. Moving tendency is horizontal here, right? Weight is perpendicular, right? So recall the things we learned in Newton's laws, equilibrium, everything, right? So all previous things matter. For the motion horizontally along the surface, there is no contribution at all from mg. That is perpendicular. That is neglected. Perpendicular force, no? Right? Now, at one point only, it starts motion. Can you see? At one point only, it starts motion. Which means friction is counterbalancing the applied force up to some extent, isn't it? Up to some extent, it balances. When I apply 1 Newtons, it's at rest. 2 Newtons, it is at rest. For 3 Newtons, it is at rest. But for some value of Newtons, it starts motion. Right? Starts motion. Therefore, the idea you need to take out from here is this. Listen. The idea you need to take out from here is this. Listen. The idea you need to take out from here is friction counteracts the applied force up to some extent. Now, when I apply 1 Newtons, friction was 1. When I apply 1.5, friction is also 1.5. When I apply 2, friction is 2. I'm just saying arbitrary numbers. If I increase my force to 3, friction is 3. At one point only, when my force exceeded the friction, it starts motion. Right? So therefore, that behavior of friction is called a self-adjustment. This behavior of friction is called a self-adjustment. It makes sense, no? Self-adjustment means friction adjusts as it is exactly equal to the applied force up to some point. Right? Self-adjustment. When it can't self-adjust, which means that is the point where it has reached the maximum friction. Maximum reach karna. So at the maximum friction, right? At the maximum friction, that's the last point. It can be kept in equilibrium, kept in a static condition with the self-adjustment. At the very next point, if I increase the force, it starts motion. Then it moves to the dynamic part, right? So considering this, we are going to plot a graph as well. So therefore, Understanding this point is very much important, right? Okay, write down friction force is, what is self-adjustment?
Friction does not counterbalance, so that studying extra force we apply the object has to.
Then at the self-adjustment region, is the object is static or dynamic? Static, right? Then the point is friction force is self-adjusted. Friction force is self-adjusted. Friction force is self-adjusted until friction force is self-adjusted. Friction force is self-adjusted until object starts motion. So this is the keyword here, self-adjustment. Self-adjustment. Highlight the word self-adjustment. Highlight or underline the word self-adjustment. Self-adjustment. Right? Okay, last one. Listen. Last law is about dynamic friction. Listen. Dynamic friction is independent of velocities of contact in surfaces. That is also a very special and important one. If the object is dynamic, hereafter the value of friction is not going to change. Right? There is only given dynamic mu for a surface. Only one given dynamic mu. Only one mu d. Therefore, dynamic friction is a constant, irrespective of the behavior of motion. Doesn't matter whether it's moving with uniform velocity or uniform acceleration or uniform deceleration or increasing acceleration, decreasing acceleration. Doesn't matter how it moves as long as it moves. Right? Fourth one, last law, dynamic friction force is, write down, dynamic friction force is independent of dynamic friction force is independent of relative velocities, independent of relative velocities of contact in surfaces. Dynamic friction is independent of relative velocities is adana vetanavane adu nivara kadeniga vatriga thedra relative velocities of independence relative velocities of contact in surfaces. Relative velocities of contact in surfaces. Right. Listen now. I told you self-adjustment is only possible with the static friction. No, I showed you, right? I showed you that self-adjustment is happening only with the static friction. Dynamic friction is a constant, right? Now that's a very unique behavior. Static friction is changing, but dynamic friction is constant. Something like that, right? So as the next point, write down in red with an asterisk mark. Next point, write down self-adjustment is self-adjustment is only possible with static friction. Self-adjustment is only possible with static friction. Right? Self-adjustment is only possible with static friction. Second point, keep using red. Once the motion of object is started, once the motion of object is started, once the motion of object is started, dynamic friction force remains constant. Dynamic friction force remains constant irrespective of remains constant irrespective of the nature of motion. Irrespective of the nature of motion. Irrespective of the nature of motion. Within brackets, acceleration, within brackets, acceleration, comma, deceleration, acceleration, deceleration, comma, uniform velocity, does not matter, right? It is irrespective of that, does not matter. Okay, right. Next heading. Write down variation between frictional force, and applied force of an object. Variation between frictional force and applied force of an object. Variation between frictional force and applied force of an object. Right. Listen. I'm going to consider an object which is kept on a horizontal flow like this, rough horizontal flow. This is the object, and a force capital F is applied on this. A force capital F is applied on this. Right. So if this force is applied, tell me, is there a friction act? Yes. What's the direction of friction? Opposite. So therefore, friction acts here at the surface. Let me mark using this. Friction acts at the surface to the opposite direction like this. Right? Now, look at here. One of the very important and critical parts here, again in frictional force. I'll consider frictional force here in the y-axis and applied force here at the x-axis. Right? Okay. Now initially we are starting at 0 applied force now. What if applied force is 0? What about the frictional force? If the applied force is 0, frictional force is also 0. So therefore, graph starts here. Graph starts at the origin. Right? Now, if I increase the applied force by a bit, right? What about the friction? Is there a friction? Yes. And what can you say about the value of the friction? Equal to applied force, equal to F, equal to applied force, right? If I increase that applied force by a bit again, friction is adjusted as it is equal to applied force, because that is what is meant by the self-adjustment, right? There is a self-adjustment. So if it is adjusting equally, which means when friction equals 1 Newton, when applied force equals 1, friction is also going to be 1. When this is 2, this is also 2. So therefore, that is y equals x curve. That is like y equals x. Y equals x means there is going to be a curve that is exactly in between these two. If you measure this angle, this is going to be exactly 45. Right? Mega 1 to 1, 1.5 to 1.5, 2 to 2, 2.5 to 2.5, 3 to 3, likewise. Got it? And at one point, it is reaching its maximum point. And just after that point, if I further increase the applied force, What's happening to the object? Starting motion. But we know mu s is greater than mu d, no? So therefore, maximum static friction should be greater than dynamic friction, no? F equals mu r, but mu s is greater than mu d. So maximum static friction should be greater than dynamic friction. Therefore, hereafter, this drops a bit and continues to dynamic friction. This drops a bit and continues to dynamic friction. Right? And this variation is an experimental result. Right? But using laws, we can verify all these things are correct. I mean, initiation of this is an experiment. Right? But using all the laws, now we can verify this. This point is very important. This point is very important because this is the maximum ever friction the object has gained. That is called the limiting friction. This is called the limiting friction. That is called the limiting friction. Right? And any point before this, at this side is, what about the object? Static or dynamic? Static. So therefore, any point before this is a static friction. Any point after this limiting point is dynamic friction. And the region from, let me label this as O, A, and B. Right? O to A, region from O to A is called self-adjustment region. Right? Region from O to A is called self-adjustment region. So therefore, friction is a very unique force which has unique features that no one else has. Right? වෙන කිසිම force එකකට නැති ඒවා මේ friction එකට තියෙනවා. Right? About the exerting, formation, adjusting, behavior, everything is different from all other ordinary forces. Friction is a very special force. So that's the exact reason that we have to learn about friction as a separate chapter. If there is just another force, this is not just another force. Right? So starting from here, this is self-adjustment region. අපි ඒකත් label කරමු. This region from O to A is the self-adjustment region. From O to A, that is self-adjustment region. Once the motion is started, doesn't matter how the motion behaves, it is a constant. Dynamic friction is a constant. Right? So there are two variations coming up. This is the first variation. And both variations are playing a critical role here when it comes to our questions. So therefore, you have to know this behavior exactly. If the force is applied, repeating again, if the force is applied starting from 0 up to some point, it will be self-adjusted. And at one point, it is reaching its maximum possible friction. That is called limiting friction. If my force is increased beyond that limiting friction, it starts motion. Right? Once motion is started, doesn't matter how we increase this force again, always dynamic friction is a constant. Right? Take this down. So, yeah. Not this part. Box and the graph. So, sir, is mu static in mu s greater than mu d the highest static friction? Mu s is defined for limiting point only. That's what I explained in the definition. Mu s is defined only at the limiting friction, only for the limiting point, because it cannot be defined for other points. The reason is there are infinite points from here to here, but limiting friction is only one point. So that's a practical point that we can do the definition. And no need to define infinite number of mu's for other points because it is self-adjusting now. If we know the applied force, which means we know friction. No need to apply F equals mu r for self-adjustment region as it is equal to the applied force. Mu r done, right? So therefore, no point of finding it out. And actually, in practicability, in terms of practicability, it is totally impractical to find these infinite points, right? So if I compare this with something in center of gravity, can you remember this stable, neutral, and unstable equilibrium? For stable scenarios, we had infinite points, but only one neutral, something like that. We have infinite self-adjustment points in static region, and we have infinite dynamic points as well. But since dynamic friction is a constant, it is practically gettable. That's a constant. But here, since there is only one limiting point, definition is done only for the limiting point.
Changing the friction to the dynamic friction also depends on the V, right?
It
Depends on the V, right?
I didn't get the point. අඩුවෙනවා හරි values දෙකේ difference එකද? ඔව් difference එක එනවා. gap මේ කියන්නේ මේ fold එක drop එක කොච්චරද කියන එකනේ. ඔව්. හොයන්න පුළුවන් නේ mu s nu d දන්නවා. එතකොට ඉතින් හොයන්න පුළුවන්. Okay, finish. Right, write down below with a red pen. First point below the diagram. First point, limiting friction. Limiting friction is the maximum ever. Limiting friction is the maximum ever friction, or say maximum possible friction. Limiting friction is the maximum possible friction. Limiting friction is the maximum possible friction the object can gain. The object can gain the object can gain. Second point, mu s is defined. Keep using red. Mu s is defined. Mu s is defined. Mu s is defined at limiting point. Mu s is defined at limiting point. Third point. Therefore, only limiting friction. Therefore, only limiting friction can be determined. Therefore, only limiting friction can be determined. Therefore, only limiting friction can be determined when F equals mu r is applied. 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 Right. Next. Write down excellent. Variation between. Right now it's since it's getting late for the students to pray. Right. We'll take the break now. Right. We'll take the break now, and now we are at the very last part of the theories of frictional force. Right. Friction. We are at the very last part. There is another variation coming up, and after the variation there are few more things, and then we are going to see some questions, see some sums, applications, how this is going to work, right? Okay, so we'll start the next variation after the break. Now it's 5:52, right? Come back again in 10 minutes, 12 minutes, 12 minutes. Okay, so take the break. Yeah, the enrollment keys, I didn't mention. Enrollment key for the paper class is I couldn't mention the enrollment key before. This is the enrollment key for the paper class. Both P's are capital, uppercase. Uh, right? This is also capital. Right? I couldn't mention the enrollment key for the paper class before, right? So this is it. Capital P simple S at capital P H Y 27P. This is also capital. All P's are capital P's. That's the key. I couldn't mention before. Now for the right. No, I muted. Okay. Someone asked a question. Okay. Right. Listen. Right. So before the second variation, this is something you should know before it. As a note, take down trigonometric variations. Trigonometric variations. Trigonometric variations. If you are doing combined maths, you already know this, right? And here what I'm going to discuss is the part that we need for A-level physics. Otherwise, in combined maths, more extent of these variations are there, right? This is what we need for our subjects. For our subject, right? Trigonometric variations. Trigonometric variations means like this. First variation is sine theta with theta. Right? How sine theta varies with theta. Right? Combined math students. What's the variation of sine theta with theta? Sine theta with theta. What's the maximum possible value of sine theta? Minimum possible value? -1. What kind of a variation? Linear, unlinear, okay, shapes, what's the shape? Oh. You're doing bio, no? It's called sinusoidal. The shape is called sinusoidal. Yeah, sinusoidal, or it's called the Wavic shape, Wavic. Right? So therefore, varies like this, something like this. To see the variation, to see the shape, I'm drawing further. Otherwise, for physics, we only need the variation from 0 to 90. We only need the variation from 0 to 90. Right? I draw the variation because to you to see the pattern, see the shape. Right? Now it goes like this. Maximum value of sine is +1 and minimum value of sine is -1. And this is 0. No? This point is 90. 90 means pi over 2. Right? This is 185. And at this point, now this goes, this is 3 pi over 2. And this is 2 pi. And it goes on. For physics, we only need the variation between 0 to 90. Knowing the variation between 0 to 90 is enough. But if I just draw this one, you don't see this nice shape, no? That's why I drew it further. Right? Natural 720 physics it's up to 90 only. Right? Sine theta. What about cos theta? What about cos theta? What's the maximum value of cos? +1. Minimum value? -1. Shape? Same. But cos 0 is 1. Cos 0 is 1. So it is like this exact same graph is shifted by another 90 degrees. Like this. Starting with 1. like this. Starting with 1. Same shape. This is plus 1. Plus 1. Minimum value is minus 1. And 0 is here. Cos 90 is 0, no? That you know from projectile motion. You know the values of the specific angles like 30, 45, 60, 90. Right? So this is 90. And at this point, this is 3 5 over 2. And here, oh, wait. 90 and 5 and 3 5 over 2 and 2 5. So likewise, it goes. Likewise, it goes. This is the cost variation. And the last one, now here also knowing up to, I mean, from 0 to 90 is enough. Last one is tan variation. For tan variation also knowing up to 90 is enough, but to see the proper shape, I'll be drawing it a little bit further. Right. So what about the tan variation? What's the value of tan 0? Tan 0. Huh? Tan 0 is 0. Tan 0 is 0. Value of tan 90? Infinity. Right? Tan 0 is 0. Tan 90 is infinity. 90, 180, 270, 25 and it goes, and this is minus 90. I'm drawing minus 90 to see the correct shape. Right? So what you know is tan 0 is 0 and tan 90 is infinity. No? Variation is like this. This goes up to infinity from either of the ends. Right? From both ends. This is called the tan variation. And here we are drawing this line parallel to this to say that, to indicate that it is going up to infinity. Right? And here it comes from the other side like this. Like this. This is the tan variation. Right? Here also, knowing from 0 to 90 is enough. Right? මේ shape එක බලන්න තමයි මේ ලඝුවට ඇඳලා පෙන්නුවේ. Otherwise, knowing up to 0 to 90, from 0 to 90 is enough for physics. Huh? Right? Know these shapes because knowing whether it's sinusoidal, these two are called sinusoidal shapes. Right? For this, there is no particular name, but this is how it varies. Know these shapes. For calculations, we only need 0 to 90. Okay, take it down. Maths අය මේක දන්නවා කොහොමද? This is actually for bio students. Take it down. Trigonometric variations. Huh? First day of units and dimensions. You were there, right? Huh? Angles. What is phi? Huh? What is phi in angles? Phi radians. Phi is 180. First day in units and dimensions. Two different things. Two different models of phi. Same symbol. Same symbol. This is radian phi. Radian phi. Radians. Right? අරනේ මේ දන්නවනේ. 90, 180. Phi equals 180 degrees. ලැජ්ජයි ඈ. First day of units and dimensions. I proved 2 phi r. Circumference is 2 phi r using this on the first day. Right? Okay, take it down. In combined maths, there's a term for this. Actually, I can't remember. That's why I'm asking. In combined maths, there's a term for this. Online students? Asymptote, yes. Thanks. Asymptote. None. Yeah. Asymptote. This is called an asymptote. Alright. Okay, finished? Now, if you have enough space, you can draw all three like one by one parallelly. Extend you can extend all these lines at once if you are drawing one by one parallelly. Right? Now, since I ran out of space, I had to take this to the other side. So on the page, if you have the enough space, extend all these lines and draw all three at once. Right. Right down below with a red pen. Variation between 0 and 90. Variation between 0 and 90. Variation between 0 to 90 actually. 0 to 90. Variation between 0 to 90. 90 is 5 over 2. Is enough for A-level physics. Is enough for A-level physics. මම note එකක් දැම්මේ නැත්තම් මේක දැකලා බය වෙයි කියලා. Is enough for A-level physics. But for your higher studies, you need all these variations. I mean, beyond 90. For A-level physics, going up to 90 is enough. Right? So the final learning is sine is increasing from 0 to 90, while cos is decreasing sinusoidal 0 to 90, and tan is also increasing from 0 to 90. Right? Right. So for the angles beyond 90, tan is in a decreasing trend. So that's why if I connect this with some gradient things, right? What type of a gradient is this? What type of a gradient is this? දැන් මේක linear motion කරද්දි කියන්න බෑ. ඉතින් ඒක ඒතකොට කියන්නේ නැත්තේ. Negative increasing. Negative increasing. And this gradient is negative decreasing. Gradient is tan theta. Gradient is tan theta. Right? See, for obtuse angles are here. Obtuse angles are the angles greater than 90. No? So obtuse angles are here in this region. Obtuse angles are here. So what is happening is that negative value is coming from here to here. So that is why when the angle increases, see, when the angle increases, that is negatively increasing. Right? මේකටත් ඕක connected because m is tan theta. Right? M is tan theta. When that angle decreases, it comes this way. Correct? Okay. Finish? Next heading, write down variation between topic heading, next heading. Variation between frictional force and angle of inclination. Frictional force and angle of inclination. An angle of inclination of the surface. Right. Look at the board. So this is what we are going to consider now. An object which is kept on an inclined plane, right? Kept on an inclined plane. And what we are trying to plot is the variation of frictional force with this angle. Variation of frictional force with this angle, right? So initially, we will be starting from 0. If the angle is 0, the surface is horizontal. No? If the surface is horizontal, what about friction? Is there a motion? No. Is there a moving tendency? No. Is there a friction? No. So therefore, this graph also starts from here. So that I have identified already, right? And now I'm going to consider one angle here before the motion starts. Before the motion starts means in which region that is? Before motion. Yeah. Before motion, that is at the self-adjustment region. Before motion, which means now this is static. Now this is static. Static. Before motion. Now, see, if you identify these forces, mgx, no? mgx, and this is also theta. Towards this direction, mg sine theta. And towards this direction, this is mg cos theta. Right? Now, moving tendency is downwards the plane. Therefore, friction acts upwards the plane. Right? Now, if there is no motion, there is a static, no? If there is no motion, what about these two? Equals. They are equal. Right? Before motion, there is a static. Since there is a static, these two forces should be equal. So therefore, downward force here is mg sine theta. Upward force here is F. Right? Now we are going to plot F. Right? Subject F. Now F is mg sine theta. F is mg sine theta. But mg is a constant. Mg is constant throughout the motion. No? So therefore, let me remove this for a moment. Mg is a constant, which means F depends only on sine theta. No? Isn't it? F depends only on sine theta. Right? Now the angle is acute. If the angle is acute, now if behaves with sine theta, when theta changes, F behaves with sine theta. If you have a trigonometric variation for a given quantity, that shape takes the exact same shape of that trigonometric variation. Got my point? Now, if friction changes with sine theta, and you know how sine theta changes with theta. So therefore, if you have a trigonometric variation, this is called a trigonometric variable. Trigonometric variable. If sine theta was a constant here, that's a different story. That is not going to behave if that's a constant. Now, when theta changes, if theta changes, see, theta is a variable. When theta changes, sine theta changes. Now, trigonometric variable is here. If there's a trigonometric variable, that particular trigonometric variable will follow the respective trigonometric variation of that particular ratio. Got the point? Frictional force is following the variation of sine theta because F is proportional to sine theta. That is for mu, not for the friction. That is for mu. For the coefficient, this is friction may force again, right? So friction follows the variation of sine theta. We know variation of sine theta between 0 and 90 is increasing, decreasing, or what is happening? Increasing with the decreasing rate like this. So therefore, for this part, the variation of sine theta comes. This is the first part of sine curve that we draw, right? And then at some point, this object starts the motion. No? Now what happens? Before motion. This is after motion. After motion. After motion is started, which means there is dynamic. Right. If there is dynamic, are they equal now? No, they are not equal. They are not equal. But we know, I haven't marked it, there's a reaction force acts here. Say R, perpendicular reaction. Total reaction is R, right? for any moving or unmoving object, we can apply the general equation, no? F equals mu r now, right? Now this is actually about Fs, Fs. This is actually Fs, and here this is actually Fd, right? Equals mu is mu d r. R is, what is R? Mg cos theta. R equals mg cos theta, right? Mu d, mg cos theta. Now in this case, this whole thing, mu d and mg are constant, which means this Fd follows the variation of cos theta. So therefore, draw the respective variation of cos theta between 0 and 90. Between 0 and 90, cos theta is decreasing with an increasing rate. Okay, cos theta is decreasing with an increasing rate. So if you can't remember, just go back to the previous page and see. Right, just go back to the previous page and see. It is decreasing, but we know at this point, the very last point of the static friction is what? Limiting friction. Limiting friction, and static mu is greater than, again the same logic, dynamic mu, right? So therefore, there should be a drop again when it is switching from static to dynamic. It drops, and the variation follows the rest. Got it? This is the variation of cos theta between 0 and 90. Because this whole thing happens between 0 and 90. Once it comes to 90, it falls down without having any contact. Before 90, it falls down without having any contact. Therefore, this whole variation is between 0 and 90. Dynamic frictional force is a constant. Here, now dynamic friction is constant, but it varies with the angle now. It is constant for a given surface. Now we are changing the surface, angle of the surface. So therefore it changes. Got it? Otherwise dynamic friction is a constant. Angle එක change වෙනොත් change වෙනවා. ඒක තමයි මේ කියන්නේ variation එක. This one. This drop is due to this mu s to mu d. Because at some point when it switches from static to dynamic, mu drops. When mu drops, frictional force drops, and at the very next point it is starting motion. Then it follows this cos variation. That is transition. This part is transition, right? Transition means during this part, listen, that's a good question. So during this drop, during this fall, that is where the object starts a motion. Body time to move it from static to dynamic, right? There's a small time duration in between, maybe a millisecond something. That is here. Transition period. Transition. Good. Take it down. These two are the two variations you have to learn as theories. But when it comes to questions based on these two, right, modified questions, creative questions are also coming. But without knowing these two basic variations, you can't do anything. These are the two variations we have in our guide, teacher's guide and syllabus to us to teach you. But when it comes to questions, creative questions are coming. Right, take it down. So would it not start moving before 90 degrees? It starts, and it depends with the nature of the surface, right? So I haven't drawn the graph up to 90. This is the variation between 0 and 90. Variation between 0 and 90 is anyway declining. That's why. Right? So part of this variation has come here like this. See? So I'm not saying this whole pulse is here. No. I'm not saying this whole pulse is here. Right? මේ pulse එක මෙතන තියෙනවා කියලා කියන්න බෑ. We can't say that the whole pulse is here. No. එහෙමයක් නැහැ. You can't say that whole pulse is here. Just a part of this. Like this. Just a part of this. and from the cost variation, another part of the cost variation. Right? So these are the things we have as the cream of friction, right? These are the best things in friction: self-adjustment, limiting friction, variation with applied force, variation with angle, right? Friction is not just another resistive force, very unique force. Friction is the only force, it has this kind of a complex behavior in the world. Only force with this kind of a complex different behaviors in different stages, right? Very strange, right? If no force is applied, no friction, but at the very point of force is applied, friction exerts, right? So until then there's no friction, but at the very point it exerts. It's a very unique one and a strange one, right? And if we increase the force, it also increases, and it's trying to like keep a battle with us, something like this. If we increase, it also increases, but at some point it reaches the limiting point and start the motion. Self-adjustment is the most unique thing about friction. None of the forces can be self-adjusted. Automatically adjusted. Self-adjustment is an automatic adjustment. That's the most unique thing about the frictional force. Finished? Finished? Right. Listen. Finished? Right. Listen. Now from here, all the theories here in friction is done. Right? All the theories are finished now. All the theories are finished. Right? Which means we are going to start all the applications in friction and going to finish friction by the next day itself, by starting with the simple applications and ending with the advanced applications. But friction is a small lesson, even though it has more connections, more links with the other ones. Friction is a small lesson. It connects with linear motion, it connects with can be connected with projectile motion, and connects with rotational, circular. For everything it can be connected. Right? So therefore, even though it's small, it's playing a role. Right? Very small lesson, friction. Right? Listen. So therefore, next day will be a full day with applications of friction. Right? So any questions about friction up to here? Any questions about friction up to here? Right? I'll give you a small food for thought. Right? Think about the direction of friction. I mean, later, think about the direction of friction when we walk forward. Think about the direction of friction on our foot when we walk forward. Right? I'll ask this question again next day. Right? You can think throughout the week and tell me what is happening. Right? Don't ask ChatGPT. Right? Just think. Let your brain think, not that artificial brain. Right? So then ChatGPT will learn because it's a machine learning algorithm. Once you ask a question, it also learns it. If it is a fact that is not known to the algorithm, it takes that as a fact. That's a nature. Right? That is very much similar to human learning process. Now, if you heard about something that you didn't know before, right? We will take it to our memory now. Right? If I say something that you didn't know before, say not a subject related thing. Say I said you something about some say magical fact, a strange fact about something that you didn't know before, then you are storing it in your head now. So similarly, ChatGPT is doing the same, because there are things that ChatGPT doesn't know. There is something like that. That algorithm is also learning real time, right? So therefore, don't ask GPT or Gemini or whatever it is. ChatGPT it is Gemini. Don't ask them. Just think what is happening. What is happening when we are walking forward. And I will give you a hint as well. Try to walk barefoot slowly. Then you will understand something. Try to walk barefoot very slowly. Right? I need the direction of friction on foot when walking forward. Right? So if I forget to ask you the question next day, remind me. Right? Online students, remind me. Right? So I need the direction of friction when we walk forward. Right? Huh? Huh? Sorry? Don't. Right. Any other questions? Any other questions? Any question to clarify? Anything to clarify about the things here? Now, this is the complete theory part in friction, right? This is the complete theory part. So I completed all theories today because even if someone outside in the sense someone who is not in the regular batch is watching the YouTube video Zoom or whatever it is just for today, right? Now for them also, now they know that the theory part of friction is completed from here. Then they can start trying questions if you are someone outside joined just for today, right? Because that's an endpoint here, no? Right? Theory so that's why I completed all theories before going to sums, before going to applications. Right? Any questions? Any questions? So what about friction? Interesting, right? Yeah, in reality, that's the only force which has this kind of a complexity. I would say not a complexity, but some interesting facts, right? Other forces are just ordinary forces, constant, maybe variables, but not such a behavior, right? Friction is a very interesting force. And with that, the complexity is also added for friction. I mean, complexity is there, some added complexity is there. That is how the thinking is involved here. What about online students? How was friction? Theory coverage, theories of friction. Now, before today, most probably what you know about friction from O levels is that is just a resistive force acting opposite to motion. That's what you know from O levels now, right? Just a resistive force. But these are the things behind friction. If we dig deep, if you dig deep and if you think about it thoroughly. Okay. Right. Okay then. Listen. So if no any other questions, we are going to wind up. Online students, you will get the tute in the coming days. And so before next Friday, we'll be meeting this week on Wednesday, right? So on Wednesday, you are going to meet with the first paper, and on the first day, you are going to write a MCQ paper, right? You are going to write an MCQ paper. So as I told you, practice all the questions, practice all question types we had so far, and come to the discussion, come to the paper writing and discussion, right? All right, if any other thing to clarify, you can drop me a message, I mean, after the class, right? If there's any more thing to clarify. Okay then, all good? So reminding again, since the monsoon season is also already started, right? So if you are living around Central Highlands area, be very much safe, right? Be very safe and always be updated, because sometimes announcements can be given, and likewise there are things, no, evacuation announcements, those things. So therefore be updated, be vigilant especially, and stay safe, right? Study hard and work hard. See you all on the next day. So we'll be meeting on Wednesday, right? Wednesday at 6:30 we'll be meeting before the next class. And next day plan here in this class is we are going to finish friction after discussing all the question types in friction, right? And during the month our plan is, after friction you are starting rotational motion. Next thing, rotational motion, right? So during the month rotational motion will also be covered, right? Okay then, we'll wind up. All good, no? Online? Okay. So if no questions, we'll wind up. Stay safe and help each other as much as possible. And if there's anyone who seeks the support from us, right, you can contact them, right? All right then. Is it raining? No, not yet. Thundering. Okay. Then go safe and stay safe. Good night and goodbye.